Okay, so you might be wondering, what is Capex and what is Opex? Capex is short for capital expenditure, which is normally given to a client or a business user at the beginning of a year, or it's when they get their budget for operating their business during the course of them next 12 months. Opex, or operational expenditure, is then set against different sort of service level agreements or suppliers or contractors for that year ahead. A capital expenditure of £10,000 for looking after a certain set or a certain volume of equipment or machinery is quite low, but what people don't see, or what the misconception is then, is that that £10,000 guarantees you access to service engineers when you need them most, but then your operational expenditure for servicing and maintaining that equipment might be high. So in the case where we had a £10,000 capital expenditure with £180,000 a year operational expenditure, the difference between them two is massive, and that's because the initial term of £10,000 wasn't delivering the client a level of service that the equipment needed, but they didn't see that the £180,000 operational expenditure was being offset versus the contract value. Opex, which is operational expenditure, is the cost in which that term or service level agreement costs the business in additional revenue versus the Capex of £10,000 at the beginning of the year to initialise the contract. And what we do here, or what we're aiming to do with this video, is show you the difference between having a higher Opex, which is your operational expenditure or contract engagement cost, to allow us to deliver the right amount of service, the right level of parts, the right level of maintenance to all of your equipment, to then reduce your overall Opex, which is your operational expenditure. And by doing this, you save money, your equipment ends up in a better condition, and you end up with less downtime and increased uptime. And that is the whole goal of a maintenance program. So what we'll do is show you the benefits of having a higher initial contract value and getting the maintenance done correctly first time round, versus having a higher Opex expenditure when you're paying for things that you shouldn't really have to because you haven't had the maintenance or the initial contract engagement done correctly at the beginning. Okay guys, let's look at Capex versus Opex. Let's start with capital expenditure. Capex is the initial cost in which it costs you to engage a contract or a service level agreement for a fixed term or a fixed period of time. The Capex cost, which might be a small amount of money versus the term in which the contract is over, it doesn't always include the things that you need to ensure your critical plant can remain available. For example, let's take a 500 kVA machine. In order to maintain a 500 kVA machine, you need a minimum of a set of filters, a set of belts, and the equipment to carry out the testing on this machine over the course of the 12-monthly agreement to ensure that it remains in a fit bill of health and capable of supporting your operation when it's needed most. You simply cannot buy a genuine set of filters and belts for a 500 kVA machine for less than £200. So when you get an initial contract or engagement fee for an SLA agreement for a 500 kVA machine, whereby you've got a company or individual charging you for a service level agreement, which is then potentially, I'm not saying it is, but is then for £500 a year, that doesn't cover the cost in which it costs to maintain that machine. It is that simple, because by the time you've got fluid sampling, site attendance, fuel costs, and all the other things that roll into the maintenance of that machine, it simply isn't cost effective for the individual or the business to be carrying out that service correctly. So to maintain a 500 kVA machine correctly, the budget needs to be anywhere between £1,200 a year to £2,000 a year, and that is how much it costs to correctly look after a 500 kVA machine over the course of a year, because you need to guarantee that you can get one set of filter changes, you can get a load bank test, and you change the belts on the machine as and when it needs it. Now, unfortunately, in our industry, it is too easy to pay a small fee for generator maintenance and then over the course of that year pay additional, what we call operational expenditure, to guarantee that machine's health. By spending a higher Capex, so if you'd have spent here, you'd have spent £2,000 initially for the correct value contract, this Opex figure wouldn't increase. But unfortunately, the Capex value for the maintenance contract in this case was £200, but then when the engineer attends site and tells Mr. Customer that they need to pay for a load bank test, they need to buy belts, or they need to pay for the filters or the fluids for that machine, this Opex figure then goes up. So whilst the contract value may have been £200, the operational expenditure for that machine for that year then becomes an additional £1,500 for additional services required to maintain that equipment. What we do here is we look at this figure. So as a business, our Capex costs are a lot higher than most businesses. And why is that? Because we look at providing a complete turnkey solution for maintenance and don't look to increase operational expenditure for the course of the SLA agreement. Our SLA agreements include virtually every element or every piece of equipment that it takes to look at consumable materials in which it costs to look after your equipment. So we provide testing of the windings, we provide 3 yearly or belt changes as and when required. As standard, we change the filters once a year, and we come and attend site to carry out visual inspections and testing of the plant once a quarter. Now this may be of a shock to some people in the industry because they're too happy, or the industry norm has always been 6 monthly visits. But what we found having our business and providing services for clients, that 6 months simply is too far apart to be able to identify any issues that may be developing or things that may be arising that need repairing or fixing. SLA agreements really are a guaranteed or a contractual obligation to provide a level of service, but unfortunately if you don't read into what's involved in the SLA, you'll be paying very little Capex but having a very high Opex. And ultimately what we're trying to do is reverse this role that it plays within the industry and show you that by spending the initial correct amount of Capex to get the correct level of service and equipment and maintenance delivered to your equipment, it should reduce your overall Opex. Okay, so Opex, operational expenditure. What should you be expecting to pay on top of your service level agreements to maintain your equipment? The truth is you shouldn't be expecting to pay any additional Opex unless you've got what we call pre-planned maintenance or 3 yearly works involved during the course of that agreement. 3 yearly maintenance depends upon the plant operational hours and the recommendations from the manufacturer. Typically in our SLA agreements, we recommend that you change all the belts every 3 years, the fluids, the batteries, and the thermostats. Now, you could argue that you don't need to carry out load bank testing until such time that this intrusive work is completed to verify that the work has been done to a satisfactory standard and the equipment remains in a healthy condition. However, load banking changes, and in some cases it is carried out every 6 months or once a quarter, depending on who the end user is and how critical the plant is to the client. Operational expenditure should not increase unless you budget for these works to be carried out during the course of a service contract. And unfortunately what happens, or the misconception is that contracts don't cost a lot of money, such as this figure here, but then leads to a higher operational expenditure, which doesn't really get recognised because people don't put this together with this, because this is looked at as what it costs to maintain a generator in a different budget. Now, looking after a generator with a higher Capex, such as £2,000 per annum, reduces operational expenditure by a very minimum amount, unless you're planning to do any of these additional works or you've got planned changes such as planned upgrades or control system upgrades planned in, which will then push this figure up based on planned works. However, also what needs to be budgeted in an Opex, the amount of money available or made available for unexpected events. Such as machinery failure or emergency situations. However, they are very few and far between, providing that you pay for the correct amount of Capex and the correct amount of maintenance is carried out. So hopefully what you can take away from this element of this video is that the figures that you pay initially for initial contract engagement, which is your Capex cost, but versus how much it costs you in overall Opex to maintain that plant, versus what if you pay for a higher value Capex to have the correct level of service and maintenance carried out, versus what it then reduces your overall Opex expenditure by a very big amount depending on what's happened during the course of that 12-month period. And unless you're planning to carry out these 3 yearly maintenance works, or you're looking to carry out additional load banking or services to be delivered to that piece of equipment or site in particular, then you shouldn't expect, if you've got the correct Capex budget for the generator maintenance contract, to see any increase in overall operational expenditure. So hopefully that's clear, and if you've got any questions, please drop it in the comments below, we'll come back to you. But for now, that gives you the best idea of what Capex and Opex does for you, and the misconception between paying a small amount for a large amount of Opex, or paying the correct amount for the contract engagement and receiving the correct level of maintenance and service delivery, which can reduce your overall Opex. One of the common misconceptions with generator maintenance is the valve lash doesn't need to be adjusted. You might be asking, what is valve lash? Valve lash is the distance between the engine's rocker arms and the valve bridges themselves. It's also the distance between the fuel injector and the injection module itself. Failure to adjust these can lead to failures, and unfortunately, due to the recommended service levels by the manufacturers, and they often get ignored, some of the defects that it can cause are drop valves, intensive wear of the valve seat itself, and also it can cause the excessive fuel consumption if the injectors fail to be adjusted accordingly. Manufacturer and OEM specifications specify that these valves should be adjusted initially at 250 hours of engine running, and also then therefore at and after every 500 hours. Failure to do this can cause catastrophic failure if the valves fail, and as I said before, it can also lead to increased fuel consumption, which can be a good telltale sign that the engine needs the valves and the injector adjustments to be completed. If you don't carry this out at the specified intervals, it can leave you with unreliable pieces of equipment, it can lead to hard starting, and it can lead to a catastrophic engine failure should it be used to the point where the valves become that worn that they can fail and drop into the cylinder itself. If you don't carry out the adjustments, you also won't get any OEM support from the manufacturer, because they'll ask you when this was last carried out and basically compare it to running hours of the engine and then not offer any OEM support at the end of it. So it's a very big and very vital piece of the maintenance regime. You should ensure that this is being completed as part of your SLA agreement with your current provider, because failure to complete the valve lash adjustment means you're not getting a comprehensive service delivery at all. Let's move on to what should I be getting in my maintenance and service contract. One thing you should be ensuring is that your primary and secondary fuel filters are being changed, and that the main engine oil filter is being changed, which is on the opposite side of this engine in this case. These primary and secondary fuel filters need to be changed on a regular basis to prevent the top seals becoming dry and the filter becoming attached to the filter housing itself. If this happens, what you can end up with is a filter that's stuck to the actual filter housing itself, and then this filter housing then gets damaged or broken in worst case scenario during filter removal, which can lead to unplanned downtime and the requirement to replace additional components during a service visit. These filters are recommended to be changed by the OEM every year or every 500 hours of engine service, whichever occurs first. The actual filter manufacturers themselves recommend they're changed at least once every 12 months to ensure that it doesn't happen whereby the filter becomes stuck to the housing. Another thing that you've got to watch for is that if the filters are excessively old, such as 2 to 3 years, is the filter elements inside can become damaged, and when the filter is put under extreme pressure, or is actually the engine's just running under normal conditions, the internal filter components can collapse, stuck, and block the supply of fuel to the engine in worst case scenarios. So it's very important to ensure that these are changed on a regular basis as part of any maintenance regime. Another thing that's often missed during a routine major or minor service visit is the fact that these charge alternator belts and fan belts deteriorate over time. We normally change belts during service visits in most scenarios where these belts have got the original paint marks on them from the factory, and unfortunately these need to be changed at least every 2 to 3 years as per the OEM specification. Why, you may ask, is these belts are made up of rubber, and whilst they're made up of durable rubber, the rubber doesn't last forever. It's a little bit like the tyres on your car. If they're left for a long period of time, they can become cracked and worn and deteriorate over time. Belts with cracks and deterioration marks or stress marks can fail under stress or under load, and in this case where they operate under extreme volumes of tension, can snap, jam the fan, and worst case scenario cause the fan to explode and burst the radiator. So it's extremely important to ensure that the charge alternator belt and the fan belt are being changed every 2 to 3 years as a minimum. Let's talk engine starting systems. In this case we've got two 12 volt batteries connected in parallel that provide 24 volts to the engine starter motor itself. What can happen with these batteries if the cells become dry is they can explode in worst case scenarios, or simply become flat and not allow the engine to start under extreme conditions. One thing to note during a maintenance or service visit is the alkaline water levels inside the battery should be checked and topped up to the adequate level. Failure to do so will cause premature battery failure or premature deterioration, but this can be monitored during the service visit as well by carrying out what's called a drop test, whereby the coil crank and amp capacity of the battery is monitored and measured over the time that the service and maintenance visits are carried out, to ensure if you've got a depleted cell or a depleting battery, it can be replaced before it causes you a failure or a headache. The other thing to make sure as well, not so much in this application but in a different application whereby the generator is installed in the building, is to ensure that the correct type, whether it be wet or lead acid or AGM battery, is to ensure you've got the correct charger installed and the batteries aren't suffering overcharging, undercharging or cell damage as a result of the incorrect charger being fitted to the application. Let's talk about AC generator maintenance. Now, one of the things that we always check as a matter of course during any service and maintenance visit is that the connections from the load output of the generator are tight and within torque tolerances. The second thing we also check within this cabinet is the connection of the earth to the neutral bar and the outgoing load connections to the supply. What can happen in the event of one of these becoming loose is you can subsequently lose loss of supply or have a catastrophic failure, which will cause a catastrophic failure of the outgoing load cables from the alternator. We also check that the breaker settings are within tolerances and complete a torque check of all the LV, DC and control connection cables within the control panel itself. Okay guys, so you join me on the opposite side of the engine in this scenario, and what we're looking at is the oil filter. This oil filter should be changed initially at 250 running hours of the engine from new, and then at every 500 hours of operation. They should be changed at the same time that oil is changed to make sure that the new oil is filtered and any contamination or debris that have entered the engine crankcase itself is filtered out in a safe manner. This filter needs to be changed at every 500 hours mandatory to ensure that the engine can operate at its peak performance, because if again in the same sort of scenario with the other side, if the seal becomes dry at the top, you can end up in a situation where this filter can't be broken away from the filter housing, and subsequently you end up with additional damage and needing to replace additional parts if it's not completed at the correct intervals. Let's talk about thermostats. Manufacturers or OEM recommendations suggest that thermostats should be changed every 2 to 3 years. The reasons for this is that the engine is kept at a constant temperature of 40 degrees and operational temperature of between 80 and 90 degrees. Thermostats don't last forever, and sitting in that constant hot and cold temperature causes them to deteriorate. The thermostats need to be changed along with the gaskets that surround the thermostat housing itself to ensure your engine can remain in a reliable and operate at its optimal performance levels, and that you don't run the risk of having a situation whereby the thermostats end up being stuck open or stuck closed, causing the engine to fail from either overheating or overcooling, which would leave the engine unavailable for operation. Okay guys, let's talk about AC alternator maintenance, what's involved and what specifically does this piece of machinery do. This is where the electrical production takes place while the engine is running. The engine needs to run at a speed of 1500 RPM to achieve 50 Hz, which is the frequency the UK or National Grid operates at. This varies depending on where you are in the world, such as in America where the frequency is 60 Hz and the engine is required to run at 1800 RPM. Alternator maintenance is very important to ensure that the plant doesn't suffer any failures as a result of maintenance that hasn't been carried out. There are 3 things you need to check within this before you enter this cabinet itself. You need to be electrically competent, you need to ensure the engine can't start, and you need to have a piece of equipment to prove dead within the alternator terminal box itself. Then you need to move on to your maintenance tasks. So what is the maintenance that's involved in this? Depending on the application and depending on where the generator operates, you'll need to visually inspect the alternator before carrying out torque checks on all the terminations within the terminal box. The second thing then to check is the connections between the CTs and any control or sensing wires that connect within the terminal box. If you're carrying out a routine or a 12-monthly service visit, some customers of ours like us to carry out a dielectric winding test or a PI test, which gives us an overall indication of the condition of the windings within the alternator and the insulation resistance values to ensure it's in a safe and operational condition. The other thing to check whilst you're in here is if they're fitted with anti-condensation heaters, is to make sure they're operational and there's no open circuit or damage or risk of the alternator heater failing. That is the majority of the sort of service checks that you will carry out. You would also normally inspect, although we can't show you on this video, the rear of the windings via the inspection chamber at the back of the alternator. However, you can't do it because of these air louvers in this application, but you would look up, visually inspect the windings and make sure there's no obstructions and that the windings are nice and clean and not suffering any debris entry. That sort of concludes alternator maintenance for now.